Assalamualaikum warahmatullahi wabarakatuh, and hi, we are from group 1, case study 1, hair dyes. So this is our group mate. The first one, Haikal, Ashraf, Amir, Luqman, Hairul, Afiq, Hafiz, and Hanif. Heavy metals are defined as metallic elements that have a relatively high density compared to water, with the assumption that heaviness and toxicity are interrelated. Heavy metals also include metalloids such as arsenics that are able to induce toxicity at low level of exposure. Although heavy metals are naturally occurring elements that are found throughout the Earth's crust, most environmental contamination and human exposure result from anthropogenic activities such as mining and smelting operations, industrial production and use, and domestic and agricultural use of metals and metal-containing compounds. Hence, research is needed to know more about the heavy metals.
The problem at hand is that they are in an unlabeled container in the storage room that contains an unknown chemical. Our objective is to identify the unknown chemical and design gravimetric analysis to determine the concentration of heavy metal in the assigned sample. To achieve this, our team will conduct experiments and produce data that we will use to present our study to the head of analytical lab of LPRA. We will use our knowledge of chemistry and analytical technique to identify the unknown compound and develop a method to determine the concentration of heavy metal in a sample.
The identification of element S is carried out through the utilization of the Lexter simulation. In this particular scenario, the simulation presents a situation where there is unidentified chemical stored in the laboratory. To determine the presence of heavy metal S within the unmarked substance, a gravimetric analysis is employed.
From the table, we can see that the mass of MgCl2 is the closest to actual weight mass. So, we can calculate the yield percentage by using the formula actual yield, which is 8.5341 over theoretical yield, which is 9.169 times 100, and get 93.075%.
Assalamualaikum. Now, without wasting any more time, I'm going to explain about the methodology for metathesis reaction. First, 100 ml of magnesium chloride solution and 1000 ml silver nitrate solution were mixed together in 1000 ml beaker. Right after that, the observation of precipitate produced was recorded. The vacuum filtration set were assembled together and assure that the filtration set is assembled properly. We don't want any kind of chemical spill on our table or on our clothes, do we? After that, the mixed solution was filtered using the wet filter paper. And always keep in mind that we need to repeat the filtration until the filtrate is clear. I'm sure we don't want to waste any product, so we can obtain more accurate data. Next, the precipitate was collected and were placed on petri dish. After that, the precipitate was dried in oven for approximately 20 hours. And lastly, the precipitate were weighed and the mass was recorded.
After we found the mole, we can determine the limiting reactant by find the smaller value of yield. After we found the mole, we can determine the limiting reactant by finding the smaller value of yield. We know the silver nitrate is the limiting reactant. After that, we compare silver nitrate with silver chloride, and we can find the mass of silver, and we got 12.9444 milligram. In 120 milliliter of hair dyes, there are 12.944 milligram of silver. So we calculate the concentration of silver by mass divide volume. Got 107.87 milligram per liter, or 107.87 ppm. So the hair dye is safe to use as he has lower concentration of silver from the maximum value allowed.
So for BeCl2, the calculated precipitate is 10.951 gram. For MgCl2, the calculated precipitate is 9.169 gram. For CaCl2, the calculated precipitate is 7.866. Now I will explain about the conclusion of our experiment. The objective of the experiment, which is to identify the amount of heavy metal content, was successfully achieved by using the gravimetric analysis method, which involved metathesis reaction based on our lab state simulation, and also to identify substance X, which is magnesium, since the theoretical yield is the closest to the actual yield. So now, based on this graph, we can see the mass of heavy metals and identify the substance X. Now we move to the next slide. In a gravimetric experiment where the goal is to determine the amount of particular substance through precipitation and subsequent weighing, the reaction between magnesium chloride and argento nitrate results in the formation of soluble magnesium nitrate and a white precipitate of silver chloride. By knowing the stoichiometry of this reaction and the molar mass of silver chloride, the amount of silver present can be calculated, which is 8.53 for 1 gram. And last but not least, based on our research, silver is not a common hair dye ingredient, and it might not be regulated or approved for such use, since the absence of proper regulation and testing could pose safety concern, which prove that it is not safe to use. And that's all from us. Thank you.